Hey, Donut Mate. How space around your body is processed by your brain? That's the question. The space around your body is processed for possible actions. Whether you're standing, walking, or driving a car, this computation will be different. Let's dive into details. The visual signal is roughly divided into two streams. A ventral what stream for objects and colors, and a dorsal where stream for actions and movements. Of course, the details are more complicated, but today we'll focus on this roughly defined dorsal stream. You may be wondering what happens when the ventral stream is damaged and only the dorsal stream functions properly. In such rare cases, patients are unable to recognize objects, yet still they are able to make actions, spatial actions, like put a letter into differently oriented mailboxes. This is called visual agnosia. People do not know what an object is, but they are able to manipulate it in space. The visual information processed by the dorsal stream eventually reaches the parietal lobe, where it is combined with the auditory where stream and with somatosensory signals, such as pressure, pain, temperature, proprioception. The parietal lobe is only one of the many multimodal areas in the brain. And by multimodal, I mean areas combining visual, auditory, somatosensory inputs. Further, different subsections of the parietal lobe are specialized in different functions, but we'll not go that deep in this video. Today, we focus on multimodal computation of the space around your body. Studies on the macaque monkeys have shown that these multimodal areas in the parietal lobe compute something which is known as body schema. This is an implicit sense of a location of your body in space. Sometimes, however, this sensation can be deceived. For example, in rubber hand illusion, where a fake hand is placed where usually a real hand is, and the real hand is hidden. You see something which looks like a hand, is where a hand should be, and is being touched, and you simultaneously feel a touch to your real hand. So for your brain, that's enough to construct a body schema based on the visual and somatosensory information. Illusions like the rubber hand illusion works also for a full body in virtual reality settings. The rubber hand illusion shows that visual and somatosensory information are combined to construct a body schema. It has been extensively studied in macaques. Touching a hand or shining light around the hand elicits activity of the same multimodal neurons in the parietal cortex. Similarly, touching an arm and shining light around arm also activates the same set of neurons. In other words, objects around a body part activates neurons associated with this body part. But there is more. Scientists trained monkeys with using tools, a rake for example, and neurons which previously were active for visual information around the body are now active also for visual information around a tip of the tool. Surprisingly, the same trick works for virtual reality. When a hand is displayed on a computer screen, this visual receptive field for multimodal areas works the same way as for a real hand, rubber hand, or tip of a tool. This has also been demonstrated in humans. There is a condition called neglect, where patients ignore half of their visual field. It happens usually after a stroke to parietal cortex. A typical test for the neglect is to dissect a line in half. People with neglect, as they ignore part of the visual field, will dissect a line not in the middle with a bias. So going back to this body schema and tools, there was a patient named PP with neglect limited only to the near space. bisecting lines far away with a laser pointer was accurate, but if a stick instead of a pointer was used, PP showed neglect as severe as for near spaces. This shows that the tools we use change how the space around us is processed. The space around the body is called a peripersonal space. There is a space around the hand, around the arm, around mouth. These perispaces are around different body parts. Apparently, these perispaces are action-oriented and gradual. For example, when you are on a wheelchair, your computation of the space adapts to your possible vectors of movement. And this makes sense. Space around the body has to be somehow monitored in anticipation of future collisions. This protective function of the perispaces detects obstacles and gives time for react. What is astonishing is that these spaces can be neuronally recycled into representing a virtual hand, like in this hand of a macaque monkey presented on a computer screen. In summary, the space around your body is a space for possible action. It is also called peripersonal space and is associated with a body schema extendable with tools. Neuronally, it is based on an activity of multimodal neurons located, among other regions, in the parietal lobe. So when you drive a car, run, walk, or even play a video game, visual data is processed in search for obstacles and possible movements that your body schema can interact with. In a sense, this perception, mediated by a dorsal stream of visual processing, is a perception for action.